Hello students. In this video we will learn chapter 1 of class 10 science. The name of the chapter is Chemical Reactions and Equations. We will study about the first topic, Introduction to Chemical Reactions. All the important concepts are explained in question-answer form. Watch the video till end to learn in easy and simple way. Let's start. Question number 1. What is chemistry? Answer. Chemistry is that branch of science which deals with the study of various aspects of the matter, which means its properties, its composition, its structure, and the changes it undergoes. Chemistry also helps us to explore how each other. In addition to all these, it helps us understand about the materials around us and the materials that we use every day, and finally, it imparts knowledge regarding how different substances behave under different physical conditions, when they are subjected to such conditions alone, or when they are made to interact with each other. Question number 2. What do we study in chemistry? Answer. In chemistry, we study the properties of different materials, how they interact and react with each other, and how energy is involved in these processes. We also learn about atoms, molecules, elements, compounds, mixtures, and how they combine or break apart during chemical reactions. We honor structure of atoms and molecules. Question number 3. What is meant by the word change? Answer. A change refers to the process where something becomes different from its original form or state. In chemistry, a change usually refers to a transformation in the structure, appearance, or composition of a substance. Question number 4. What are the most common types of changes? Answer. All the changes that are occurring around it into two bigger groups. These are physical changes and chemical changes. Physical changes, these are the types of changes in which only the physical properties of a substance change without altering the chemical composition of the substances. Chemical changes, changes where the substance's chemical composition is altered, forming new substances with different properties. Question number 5. What is meant by a physical change? Is a type of change where only the appearance, shape, size, or state of a substance is altered, but its chemical structure remains the same. There is no formation of a new substance during a physical change. It can be easily reversed, or we can say that it is easy to get back the original substance. Question number 6. What is the other name for the term physical change? Answer. A physical change is also called a reversible change or temporary change because, in most cases, the original substance can be recovered without changing its chemical properties. Question number 7. What are the important characteristics of a physical change? Answer. Most important characteristics of a physical change. No new substances are formed. The change is usually reversible. Only physical properties such as size, shape, color, and state are affected. There is usually no absorption or release of significant energy. Chemical composition remains unchanged. Question number 8. How will you decide that a change is a physical change? Answer. A change can be identified as a physical change if The chemistry remains the same before and after the change. There is change in the physical features of the substance like color, physical state, shape, appearance and similar features. The change can be reversed, such as water freezing into ice and then ice melting back into water. The chemical properties of the substance remain unaffected. Question number 9. Give some examples of physical changes that you commonly observe around you. Answer. Some examples of physical changes happening around us which you can easily observe are: melting of ice into water, boiling of water into steam, tearing or folding of paper, freezing of water to form ice, dissolving sugar in water, condensation of steam on a cold surface, crushing a can, stretching a rubber band, cutting a piece of cloth, breaking a glass, formation of frost on a cold window. Question number 10. Give some examples of physical changes that you rarely observe around you. Answer. Some examples of physical changes which you can rarely observe are: sublimation of dry ice, solid carbon dioxide turning into gas, formation of clouds, expansion of metals when heated, sharpening of cutting tools, rock erosion, magnetizing a piece of iron, crystallization of sugar from a sugar solution, condensation of moisture in the air into dew, stretching of a plastic material before breaking. Are physical changes slow or fast? Answer. Physical changes can be either slow or fast, depending on the process involved. Question number 12. Give some examples of physical changes that are fast. Answer. Some of the physical changes that are fast are: melting of ice cubes, popping of popcorn, breaking a glass, tearing a piece of paper. Question number 13. Some examples of physical changes that are very fast. Answer. Some of the physical changes that are very fast are: bursting of a balloon, crushing of a can, breaking of a stick, breaking of a stick, snapping a rubber band. Question number 14. Give some examples of physical changes that are slow. Answer. Some of the physical changes that are slow are: ice, drying of wet clothes, crystallization of salt from seawater, melting of candle wax on burning the candle. Question number 15. Give some examples of physical changes that are very slow. Answer. Some of the physical changes that are very slow are: wear and tear of clothes and shoe soles with use, expansion of metal due to heat, evaporation of water from a colder area or during winter, sublimation of mothballs. Question number 16. What is a chemical change? Answer. A chemical change is a process where the chemical composition of a substance is altered, with the formation of one or more new substances with different properties. It often involves a chemical reaction, and energy may be released or absorbed. Question number 17. Are the terms chemical change and chemical reaction the same or different? Answer. No, they are not same, but the terms chemical change and chemical reaction are closely related and are often used interchangeably. A chemical reaction refers to the process by which a chemical change occurs. Change is the result. Question number 18. What is the other name for a chemical change? Answer. A chemical change is also called an irreversible change because, in most cases, the new substances formed cannot be easily changed back into the original substances. Question number 19. What are the important features of a chemical change? Answer. Common signs of a chemical change include formation of a new substance, change in color, evolution of a gas, production or absorption of heat, change in odor, formation of a precipitate, solid formed from a solution. Question number 20. Give some examples of chemical changes that you commonly observe around you. Answer. Some examples of chemical changes that we commonly observe are burning of wood, rusting of wood, digestion of food, spoiling of milk, fermentation of grapes, combustion of gasoline in cars, rotting of fruits and vegetables, tarnishing of silver and other metals, formation of curd from milk. Question number 21. Give some examples of chemical changes that you rarely observe around you. Answer. Some examples of chemical changes that we rarely observe are electrolysis of water to produce hydrogen and oxygen, photosynthesis in plants, souring of wine into vinegar, polymerization reactions in the production of plastics, surface of ships or bridges, decay of radioactive substances, reaction of metals with acids, corrosion of metals other than iron, decomposition of organic matter in compost, production of ammonia in the Haber process. Question number 22. Are chemical changes fast or slow? Answer. Chemical changes can be fast or slow depending on the reaction. Some happen instantly or even years. Question number 23. Give some examples of chemical changes that are very fast. Answer. Some of the chemical changes that are very fast are explosion of fireworks, burning of a matchstick, combustion of gasoline in a car engine, mixing of baking soda and vinegar, reactions of acids and bases. Give some examples of chemical changes that are fast but not very fast. Answer. Some examples of chemical changes that are fast but not very fast are cooking of food, rusting of iron in moist air, curdling of milk, decomposition of hydrogen peroxide. Question number 25. Give some examples of chemical changes that are slow. Answer. Some examples of changes that are slow are rusting of iron in dry air, digestion of food in the stomach, fermentation of wine, Ripening of fruit. Question number 26. Give some examples of chemical changes that are very slow. Answer. Some examples of chemical changes that are very slow are formation of fossil fuels over millions of years, aging of wood to become petrified, weathering of rocks, slow decay of organic matter in very cold conditions. Question number 27. Give important differences between physical and chemical changes. Answer. Physical changes. No new substance is formed. These are reversible. In these changes, physical properties like shape, size, or state change. No heat is absorbed or evolved. Example is melting of ice. Chemical changes. These are usually irreversible. In these changes, chemical composition gets altered, energy exchange takes place, or heat is either evolved or absorbed. Example is burning of wood, coal and paper. Question number 28. What is meant by word equation in chemistry? Answer. A word equation in chemistry is a simple way to describe a chemical reaction by using the names of the reactants and products rather than their chemical formulas. For example, magnesium plus oxygen gives you magnesium oxide. Question number 29. What is a chemical equation? Answer. A chemical equation is a symbolic representation of a chemical reaction where the reactant using their chemical formulas. For example, Mg plus O gives you MgO dot. Question number 30. Why do we prefer to represent any chemical change with the help of a chemical equation rather than describing it in words? Answer. We prefer chemical equations because they are concise, accurate, and easy to understand. They show the exact proportions of reactants and products and make it easier to balance the reaction and apply the law of conservation of mass. Question number 31. Define reactants and products in a chemical reaction. Answer. Reactants, substances that start a chemical reaction. Products, new substances formed as a result of the chemical reaction. Question number 32. What is meant by the term skeletal equation? Answer. A skeletal equation is an unbalanced chemical equation that shows the reactants and products in their simplest terms involved. Question number 33. Is a skeletal equation always balanced or always unbalanced? Answer. A skeletal equation is mostly unbalanced because, in most of the cases, it does not account for the law of conservation of mass. It needs to be balanced by adjusting the coefficients. Question number 34. What is meant by the term unbalanced equation? Answer. An unbalanced equation is a chemical equation where the number of atoms of each element is not the same on both sides of the reaction. Question number 35. Which law is violated by an unbalanced equation? Answer. An law of conservation of mass, which states that mass cannot be created or destroyed in a chemical reaction. Question number 36. What is meant by the term balanced equation in chemistry? Answer. A balanced equation is a chemical equation where the number of atoms of each element is equal on both the reactant and product sides, ensuring that the law of conservation of mass is followed. Question number 37. What is the role of a balanced chemical equation in chemistry? A balanced chemical equation ensures that the mass and atoms are conserved during the reaction, providing a clear and accurate representation of how the reaction occurs. Question number 38. Which law is followed by a balanced chemical equation? Which law is followed by a balanced chemical equation? Answer. A balanced chemical equation follows the law of conservation of mass, which states that the total mass of the reactants must equal the total mass of the products. Question number 39. Of mass relate to chemical reactions. Answer. The law of conservation of mass states that in a chemical reaction, the total mass of the reactants must be equal to the total mass of the products. This is why we balance chemical equations. Question number 40. What is meant by the state of a substance in a chemical reaction? Answer. The state of a substance refers to whether it is in a solid, S, liquid, L, gas, G, or aqueous. These states are often indicated in chemical equations to provide more information about